Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to learn the third subtopic in chapter 5 states of matter called solid. To understand physical properties of a state of matter, you need to look at their arrangement of particles. We know particles in solid are packed tightly together in a regular pattern. So we need to look at these 5 criteria in order to determine the physical properties of solids. Solids have fixed shapes that are hard to break apart because the individual particles do not have enough energy to escape individually. Instead, they are going to vibrate among themselves. Compressibility means the ability for these particles to reduce in volume under applied pressure, while viscosity is the ability for this particle to flow or move around. However, compressibility and viscosity is almost impossible to exist in this state due to these solid fixed shapes. There is a plus point from this pack arrangement, where solid gonna have higher density compared to liquid and gas. There are 4 processes involving solid states. We have freezing, where liquid changes to solid. Next, the opposite to freezing is melting, solid changes to liquid. Apart from solid and liquid, there are also processes that shows conversion of solid and gas without passing through the liquid state called sublimations and depositions. Freezing is a process where liquid changes to solid. By removing heat, in other words, low temperature conditions, will slow down the movement of particles in liquid states. This will cause the intermolecular forces to build up between the particles. Hence, liquid water changes to solid ice. Melting is a process where solid changes to liquid. By adding heat, in other words, high temperature conditions, will make these particles in solid states to move faster, causes the intermolecular forces to be broken between the particles. Hence, solid ice changes to liquid water. Sublimations is the phase transitions in which solid transform into gas without passing through the liquid phase. When a substance sublimes, the molecules will leave the surface of the solid where they are held by less tightly than the interior one. So the combinations of intermolecular forces and also the atmospheric pressure is not great enough to keep the particles near to one another when they leave the solid states. That's why they change directly from solid to gas. An example of sublimations is dry ice. So dry ice bubble is an experiment that applies the concept of sublimations. If you could see, we start with solid dry ice with a very low temperature, about -70-ish degrees C. And to handle this, one cannot do it with just bare hands. They must wear gloves. When the dry ice is placed in warm water like this or in here, so this warm water used to provide the thermal energy as intermolecular forces needed to be broken in solid state as shown in previous example to finally form gas. Hence, dry ice will change directly into gas, just like this one. But in this experiment, we use soap to make this vapor all in place. Therefore, bubble containing cloudy vapor is obtained. Depositions is the phase transitions in which gas transforms into solid without passing through the liquid phase. One example of depositions is formations of snowflakes. For depositions to occur, the thermal energy must be removed from a gas, in other words, low temperature. When the air becomes cold enough, the water vapor in the air will lose thermal energy to change into a solid. So the super cold water vapor will immediately begins to condense. But by this point, it's already passed through the freezing point. So this will cause the water vapor to change directly into solid, which in this case in the form of snowflakes. Solid can be classified into 2 structural features based on the orderliness of particles. One is crystalline, another one is amorphous. From the diagram, we could clearly see the crystalline is a well-defined solid, where its particle is arranged in perfect order, while amorphous has a poorly defined shape due to the lacking in its arrangement, but still closely packed to one another. So example of crystalline solid would be metal, salt, and diamond, whereas the example for amorphous solid gonna be charcoal, rubber, and glass. Let's look at the crystalline solids. There are 4 types altogether. The first one is metallic crystal. This crystal consists of metal cations surrounded by sea of delocalized valence electrons. These crystals are soft to hard, therefore its melting point can range from low value to a higher value. And due to the mobile electrons in yellow, these metallic crystals are said to be good conductors of heat and electricity. Next, we have ionic crystal. So this crystal structure consists of alternating positively charged cations and negatively charged anions. So these charges are held together by the strong electrostatic attractions, in other words, the ionic bonding. Ionic crystals are hard and brittle, therefore they have high melting points. Ionic compounds do not conduct electricity as solids because they got no mobile electrons as in metallic bond. But they do conduct electricity or heat in molten or aqueous states. The third one is molecular covalent. So molecular covalent crystal consists of molecules instead of atoms or ions, and they are held together by the weak intermolecular forces. They can be either dipole-dipole or London forces. But some molecular crystals such as ice have molecules held together by hydrogen bonds. So the intermolecular forces holding the particles together are far weaker than either ionic or covalent bonds. Therefore, a fairly soft crystal is formed. As a result to these, the melting point of molecular crystal range from moderate to low. And since there's no mobile electrons present, these molecular crystals are said to be poor heat and electrical conductor. And lastly, giant covalent crystal. So this crystal consists of atoms that being covalently bonded to its neighboring atoms. So the giant covalent crystal is a 3-dimensional and contains a very large number of atoms. So this giant covalent crystal include diamond, quartz, and also many other metalloids. These crystals are hard with extremely high melting point. Since this crystal is composed of atoms rather than ions, they do not conduct heat or electricity in any states. That's all for subtopic 5.3. Thank you.